Hi guys, this is our review part 1. It is important that you pay attention to everything that I explain right now and that you don't skip any part because I'm trying to review everything you have seen from the beginning of the third period till the last topic that we saw, okay? I'm not going to explain every single detail of the topics because you have already seen it before and you have had lots of exams. So right now I'm just gonna tell you like the punctual things of each topic that I want you to remember. And if you need extra help, please ask me tomorrow or just look on your book, on your notebook, on the hardcover book or internet or on iExcel. Do everything that is in your hands to solve your doubt, okay? But mostly ask me, right? So let's start the review. This is the review part 1 because I haven't divided it into two parts that we're gonna see today and tomorrow. It says review part 1, congruent, similar, or neither of them. We're gonna start with those concepts, okay? You might remember, you may not remember, but I guess the words are pretty obvious on what they mean. The first one says, let's look at the first figure, okay? You have two triangles, and even though you have the measurements there, you have that each side equals 5, let's suppose, inches or 5 centimeters. You can see that that both figures have the same shape. They're both triangles, and they measure the same. So they're the exact same figure, even though one of them, this one, has been rotated, okay, but it's still the same figure. If the figures match, if they're exactly the same, then we're said to have two congruent figures, okay? Congruent figures. Why? Because they are exactly the same figure. Remember, in this one, it doesn't matter the position in which the figure is placed, okay? Then second one, you have two triangles again. It is the same shape, but if you notice their size is different. Apart from the fact that you see the numbers, you just by looking at it, you can see that the size is not the same. Whenever you have two figures that have the same shape but they don't measure the same, they're not of the same size, those are said to be similar, okay? And also the figures can be upside down or they can have been rotated before, okay? And last, you have a triangle and you have a circle. They're not of the same shape. They're not of the same size. So they have nothing in common till now just by looking at it. So they're said to be neither of them, okay? I guess that those concepts are way too simple, right? Because I know whenever we saw that at school, you didn't have any problem. Then, second topic, you have reflection, rotation, okay? Let's start with the blue triangle. Let's suppose that I want to move that triangle to this side of the coordinate plate. Remember, this is a coordinate plate, this is X and this is Y. You have worked with that many times. Or let's suppose that I just want to move the triangle to the right, to this side. If I am just moving the figure without changing its position, that is said to be translation. Okay, this is translation. Whenever I just move the figure all around the coordinate plane but without changing its position, okay? Then rotation. I guess you can actually work with that one because you were really good before. So what is rotating? You change the position of the figure. Let's suppose that I want to rotate this figure by 90 degrees over the origin point, okay? I'm going to take this origin and I just want to move all this. I'm just want to move all this 90 degrees. I want to just move it like this way, okay? Just like look at my pencil. I just want to do that, okay? I want to do a spin of 90 degrees. If I move that image, then it will stay here. Okay, I know I don't have squares and I don't have like the exact same measures, but it will look like that, right? So if I spin it one more time 90 degrees, then it will stay here. And if I do it again, I sorry, it will be here. Wait for me. I'm just trying to move it so I can have it done, oops, correctly. Okay. Okay, let's suppose that I did it properly. Okay, let's suppose. So that is rotating. What did I do? I just rotated the figure. I changed the figure's position, but I did it over the origin. And then this is rotation. Let me write it down here. Rotation. I just want you to be able to identify the movements. You won't have to rotate figures. You won't have to reflect them. You just need to be aware on the movement that I'm showing, okay? So remember, you're not gonna rotate the figures or translate them. You're gonna be shown images and you're gonna say whether they were reflection, rotation, reflection. I'm sorry, I said reflection again, or translation. And last, it is reflection. Reflection, it sounds like a mirror. You know that it reflects the figure over the x-axis or the y-axis. If I tell you I want to reflect this triangle over the y-axis, then it will be here, okay? I reflected it. But let's change the figure, let's change the type of triangle because it is not that clear. Let's suppose that I have a right triangle, okay? And I tell you reflect that triangle over the y-axis, then the figure is gonna stay in the same place, but the well, it has been reflected. I don't know how to explain what happened, but I guess you can see you reflected the figure. It's just like the mirror. It works like the mirror. You don't have the figure like this anymore. Now it's been reflected and it is that way, okay? So I thought it was the eraser. This is reflection. And you can also reflect that over the x-axis and it will look like this, okay? I reflected the image. The image does not have the same position, it just been reflected, okay? And now unit rates, okay? Unit rates are one of the topics that I guess I can take like one of the most important topics in 6th grade because I feel like this information is gonna help you all your life, okay? What were the unit rates? You are trying to get an idea, or well, not an idea, we're trying to get the amount of things you did in 1 hour or how many kilometers you run in an hour. You are trying to simplify the rates over 1, okay? So let's read the first one. It says I have 250 meters in 2 hours. Let's suppose that a person told you I ran 250 meters in 2 hours, okay? And then you are trying to guess, or you're trying to see how many kilometers, how many meters that person ran in 1 hour. So what you're gonna have to do is identify the numbers, okay? The first one, the amount of things or the amount of meters in the case that person run is gonna be inside of the division, and you're gonna divide it by the hours it took that person to run 250 meters. So you just start dividing, and then you say how many times does 2 fit in 2? 1. How many times does 2 fit in 5? 2. 2 times 2 is 4. So 5 minus 4 is 1. I put down the 0. And I say how many times does 2 fit in 10? It is 5, right? So that means that, let me write it here. That person, the whole answer will be, that person ran 125 meters in an hour, or like I want you to write it, per hour, okay? She ran, or he ran, 125 meters per hour, and you're gonna do the same in here. Let's suppose that I went to the gym and I tell you I burned 5,000 calories in 25 minutes. Okay, let's suppose that I was really strong and I actually did that. Okay, so I tell you, I burned 5,000 calories in 25 minutes. What you're gonna try to do is how many calories I burned in 1 minute, right? You're gonna try to simplify the second rate to 1. You're always try to do that. Try to simplify that to 1. We did the same here, okay? We simplified that to 1 hour in this case. So I want to know how many calories I burned in 1 minute, okay? I'm trying to find the unit rate. So what do? I do the same. I identify the numbers. I know the first one would be inside of the division. And then I divide that by 25 and I say, how many times does 25 fit in 50? 2, because 2 times 25 is 50. I am left with 0. So how many times does, I put down the other 0 and the other 0, and I know by now that it will give me 0, right? So that means that I burned 200 calories in 1 minute, or per minute. Sorry, I always forget that, but you must not forget that. Per minute. If you write in 1 minute, that's fine also, okay? And of course, this is not possible. I will never burn that amount of calories in 1 minute, but we are pretending, okay? We're pretending. And last part of the review, it is distance, speed, and time. But we're only gonna work with distance and speed, okay? You had formulas, which you were supposed to learn, but I'm gonna give them right now to you. So I'm trying to find the speed. Let's suppose that one car traveled 4,500 kilometers in 120 minutes, which is 2 hours, okay? And I want to find the speed. And the formula to find the speed, pay attention, because sometimes when you were working with this, you were confused with the formula. It is distance divided by time. Okay, so you just start dividing. It says, how much was the distance? The distance was 4,500, and then you're gonna divide that by 120. So let's do it. 4,500 kilometers divided by 120 minutes, okay? And then I start dividing, and I say, like, how many times does 120 fit 4,500? And then it is 3 times, well, let's take 3 numbers, and I know it is 3. Let's do our checked. 3 times 0 is 0, 3 times 2 is 6, 3 times 1 is 3. So that means I need to subtract 360 out of this. Wait, I'm gonna move this, and I will go back later, okay? And then it is 0. Oops, I made this a 15. 15 minus 6 is 9. I put it down, and it is a 4 now. 4 minus 4 is 0. Remember that if you get confused with my division, my way of dividing, you can do it your own way, okay? And I put down the other 0, and I say, how many times does 120 fit in 900? Let's try it with 7. 7 times 0 is 0, 7 times 2 is 14, 7 times 1 is 7, plus 1 is 8. So it fits 7 times, and I am left, it was 840. And then I subtract, I made it a 10. 10 minus 4 is 6. I give it back, it is a 9 now. 9 minus 9 is 0. But guys, I want you to finish the whole division, okay? You need to add a decimal point and not a 0. And now, how many times does 100 fit in 600? It fits 5. Let's try it. Yeah. So it gave me an exact result. That is, the speed will be 37.5 kilometers per minute. Okay, and last part of it is distance. Distance is way easier than the other one. The formula is the following: distance equals multiplying speed by time. My speed was 45, my time was 4 hours, so I just multiply 45 times 4. 4 times 5 is 20, 4 times 4 is 16, plus 2 is 18. So my answer is, wait, I'm gonna sneeze. Sorry. I will not erase this video only because I sneezed. I'm so sorry. 180 watt, guys. I have the hours here, so it is kilometers. And then you're done. Okay, that is the first part of the review. I hope you understood. If not, go back and back and back again and do your best.